Hi, the second part of analysis of sequential systems. In this case, we will analyze MIDI machine containing 2 gates and 1 JK flip-flop. First question is how we do know that it is MIDI machine. Because of the existence of this bypass, I would say, connection, we omit this memory element. Assuming that not Q is 1 and Q 0, change on X can change Y or changes Y. Okay? It's asynchronously, even if it's flip-flop. Let's assume it is rising edge triggered. X can asynchronously change Y because of this connection, and that's why it is a MIDI machine example. Alright, so this information of the type of the machine will be useful when we construct state transition diagram. But we start as usual with STT, state transition table, in which you have all inputs apart from CK, which is only 1, X, and all state bits of memory. It is only a single 1-bit memory element, single flip-flop, so Q of T, and that's all. Only 2 signals on the left-hand side of this table. On the right-hand side, you always have the next state, the following state after clock, after active triggering condition occurs, and then all the outputs. In this case, also a single output line. And you fill in the table with all the possibilities. Okay, and then, as usual, you can expand this table and find first JK to be able to correctly predict the next state of the flip-flop of the memory. Okay, so you must know first the values of JK. So let's analyze what J is. J is, as you can see, NOR of X and Q. It is NOR, so it is equal X plus Q of T inverted. Okay, so let's fill in this. Plus is 0, inverted is 1. Plus is 1, inverted 0. Plus is 1, inverted 0. Plus 1 plus 1 is 1, inverted 0. So J values will be these. K is simply Q. It is a copy of Q value, Q of T. So we copy these values. 0, 1, 0, 1 is K. Now we know in each case what are the inputs of the flip-flops, and the next state will be defined when you know how it operates in the following way. J, case 1, 0, it is a set command. So set is simply put 1 on the Q. 0, K is the reset. 0, 0, don't change. 0, 1, reset. So 1, 0, 0, 0 are the next states of Q. Y, as you remember, it is the state before a change. So Y, as you can see here, it is an end of not Q. Y, it is a not Q of T times X. Not Q of T times X. Not Q is 1 times X is 0. Not Q is 0, 0. Not Q is 1 times 1 gives you 1, and not Q is 0. So 0 will be the product of the two. Okay, so STT is done. And one of the STEs is also constructed. It is the one of the STE, and the second gives you the equation for the next state, Q of T plus 1. You've got a single mean term here, so it is quite easy to obtain. It is a X, not X time, not Q of T, and at the same time it is from De Morgan's law, inversion, it's a NOR of this, as it is now. Okay, so STEs are done. The next step is to derive STD. STD in the convention, it is a MIDI machine, as we said. So the convention is to put only Q inside the circles, 0 and 1, and the values of Y will be put aside arrows. And we will derive it from this table, STD. So the first row tells us that the change from 0 to 1 occurs when there is 0 on X, and what to expect on output, 0. So the first row. The second row, let's put it the bit red, 1 to 0. 1 to 0 is the opposite direction of the change. 0 and 0 the same values as before. The third row is 0 to 0 in green, let's say. The third row is in green. 0 to 0, and X is 1 and Y is 1. So 1, 1 will be present here. And the last row, 1 to 0, 1 to 0 change is already present here. It is this change in red, but you must complete the conditions and put another 1, 1, 0. So this change will occurs when also there is 1 on input, and the output is the same in the both cases. So STD in terms of MIDI machine diagram is done. So what is missing to complete the analysis is the diagram, is the sample timing, not the diagrams, timing. And to draw the timing, you must know what's the initial value of Q. Let's suppose it is 0. What's the type of the flip-flop? It is a rising edge triggered one. Then you must know the values of input in time. Of input, there is only one input X. And also what's on the clock input in this case. Let's assume it is the case. And your task is to draw Y. And as I said in the mini lecture concerning analysis 1, it is quite important to draw Q first and then Y. Because it is easier to find them first, because Q can change only on active edges of CK, of clock. However, Y, as you can see, I have mentioned it, can change asynchronously, also when X changes its value. So first, you must be aware in which state you are. At the beginning, you are at state 0. It is stated here. 0 is the initial state. Then the following state, you must see what's happening on this edge. On this edge, you've got 0. On X, you are in state 0, and you've got X0. So you go to state 1. And nothing can change in between the two consecutive edges, active edges. What you have on the next edge is 1, but now you are in state 1 here, just state 1, Q is equal to 1. And for both cases, you go back to 0. And also in between, no changes. And then you've got 1, you are in state 0, and there is 1 on X, you stay in the same state. And the last case is when you have 0, so you return to state 0. Is it true? Once again, you are in 0 state, which is this, and you've got 1. No such. I made error. Okay, here you will stay in the same state until this edge, because you were in state 0, which was this, yeah, and there was X equal to 1, so you stay in the same state until the next. Here you've got zeros, so you follow this arrow and you change state to 1. That's okay, I hope. If you have Q, you then realize this. You must invert Q and multiply by X. Okay? Invert is 1, multiply by X is 0. So invert Q gives you 0. Then inverting Q gives you 1. Okay, within this long period of time, and you must multiply 1 by X, resulting in X. So now you simply repeat. Oh, sorry, too far. This is X change. In this point is another change. In this point is another change, and let's stop it here. Okay, you follow X because Q inverted gives you 1, so the result of and 1 times X gives you X. So I was following X changes, okay, and putting on Y. And what at the end edge, you are in state 1. In state 1, when there is 0 or the output doesn't depend on X, it is 0. Okay, you can also continue. Inverting Q gives you 0 times X gives you 0. That's another analysis, another way to find the same. Thank you.